Hello and welcome everyone to another session of the Data series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Shishir, part of data science team at Analytics Vidya, and I will be the moderator for this session. For those who have joined us for the first time, a brief introduction about the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidya, led by top industries experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is Introduction to Image Processing using Python. In this data hour is going to be an interactive code along session in which you will be introduced to the digital representation of an image and how image characteristics can be altered using Python. In this edition of Data Hour, we have with us Siddhant Sadangi from Bangalore, India. Siddhant has 7+ years of data science experience and is currently associated with Reuters, where he supports its sales, product, and editorial teams with data insights and predictive analysis. He is also a technical content writer with Neptune AI, an MLOps platform where he creates and audits their documentation, blogs, and open source code. He also has 3.5 years of experience in data warehousing and ETL with Delight. Siddhant, the virtual stage is all yours.
Thanks, Ishir and the AV team for having me, and thanks to all the participants for joining me today for this data session. Okay, first of all, let me start sharing my screen. And meanwhile, I seen chats that some of you are not able to access the notebook. Is that issue resolved?
Please, I request attendees to kindly sign in to your Google account and then open the link which I provided in the chat section. You will be able to open up the link.
And can you all see my screen? Cool, thanks for confirming. Anyone having any issues in accessing the notebook first? Yeah, the notebook will open without signing in, but you won't be able to save it. So in case you are able to see my screen and you're able to access the notebook, so let's first set up the environment. So first I will recommend everyone to just sign into their Google account. If you are not signed in, you will see an option sign in at the top right. So just sign into your Google account, then access the notebook, and you will see an option called copy to drive. I would suggest you do that so that you will be able to save changes to your notebook. If you don't copy to your, so the current notebook which is shared is read only. If you want to save changes, add your cells, take notes, it's better to copy it to your personal drive so that you can access it whenever you want to. So if you click copy on drive, it will create a copy and open a new tab with that copy. This is the version you will be using. So the new tab which has opened, you can close the previous one. Where's the notebook? You got the link, right?
Yeah, I've shared the link in the chat section also.
Cool. So everyone who has copied it to their personal drives, can I have a show of hands? If it says notebook has been moved to bin, you would have an option saying recover from bin. You can do that. Okay, so I'm assuming everyone has the notebook open now and they have saved a copy to their drive. How to know if you have saved a copy? If you go to file, you will have the rename option available. If it's not saved to your drive, if it's a read-only version, you won't have, you will have the rename option grayed out. So that's how you confirm, and you'll also see a copy to drive option if it's not copied to your drive yet. Okay, and some instructions for the workshop. If in case you have access to multiple screens, it's preferable to have the notebook in a separate screen than the Zoom session, so that like, you can access both your notebook and my screen share together. In case not, it's better to split windows. If you are using Windows, you can just click on the Zoom window and window and L. This will move the Zoom window to left. If you then select the window having your notebook, move it to the right, so that again you can see both. In case your screen is not large enough, you'll have to switch tabs. If the notebook has been moved to Thrash for you, there should be an option to recover it from Thrash. Okay, so everyone done with this step? Okay, cool. Let's get started then. So first, no option to, it's showing the drive access is not there. That's because you have not signed into Google. In case you have signed in, that should not be an issue.
The link is working. I've checked it just now.
Yeah,
So
even I checked. So, and it's a public link. Even if you don't sign into Google, you should be able to open it at least. Okay. In the interest of time, I will move on. So since this is an interactive code along workshop, at any point of time, if you are stuck or if you have questions, feel free to raise your hand, and like either me or someone from the moderator will answer, or you can use the Q&A option to like put in your questions, and either me or someone from the moderators will take it up. Okay, let's get started. First, let's cover a few basics. So what exactly is an image, or what exactly is an image when we think of the digital world? So for the purpose of this workshop, you can consider an image as an array or a matrix of square pixels arranged in rows and columns. So for example, if you see this image here, you can like consider it to be a grayscale image. So it is basically a collection of different pixels, right? So if you think of a matrix, you assign numbers to each individual elements, and then you assign it you assign those numbers a brightness based on their value. So 0 in this case means there is no brightness, it has no value, and the highest value will be 255, which is absolute white. So that can be called a grayscale image. It does not have color. It's the image only ranges between, say, different shades of black and white or gray. So this is a grayscale image where the pixel value determines the shade of gray. 0 for black, smaller colors for darker pixels, and 255, which is the maximum value possible for white. Now, in case of a color image, think of it as this same thing, this same grayscale image multiplied by 3. So 1 for each color channel. A color channel is basically it depends on which color channel you're looking into. There is a separate channel for red, blue, and green. So in case you have like seen old LCD screens or CRT screens, if you would have squinted, you would have observed that each individual cell is made of 3 separate colors, and the color which you see is a combination of these 3 colors. So the intensity of those channels will determine how red, green, or blue that exact pixel will be. And since red, green, and blue are primary colors, you can like combine them in different combinations to create any other color using them. So you see example of how CRT TVs look like and how LCD screens look like. So it's basically like each pixel is a combination of these 3 colors. You can also, like, if you squint hard enough, you might be able to see it in modern screens, but in modern screens, the pixels are very small. Okay, now let's start with the coding bit. So the first thing you need to do is you need to connect the notebook. If you see an option to connect, you can click on connect and it will allocate resources for your notebook. And once that is done, we will just import a few libraries which are needed. So matplotlib, we will use it to render and plot the images. NumPy, and since I mentioned that image is basically an array or a matrix, we'll use this to like convert the image to a matrix. Request is just used to import the image. PIL or Python image library is one of the standard imaging libraries of Python, the other being OpenCV. Okay, is my screen too small for you? Is it better now? Okay, cool. I will use the zoom level then. By connect, I mean if you go to the top left, in case you haven't connected, you will see an option called connect. So just click on it. It will allocate resources to your Colab notebook. So once it's connected, you will see this green tick and the RAM and disk usage. So once that's done, I'm assuming all of you know how to execute notebooks. So just click on this cell and execute this. It will import all the libraries which we need. So once that's done, let's see how our image looks like. This is the image which we'll be working with now. Okay, and anyone who was seeing move to Thrash, you can make a copy. So this is the image which we'll be using for the workshop. Anyone who has worked with computer vision applications before would be familiar with this image of Lena. So first, let's save this image as an array and see the dimensions of the image. Now, first question for the participants, there'll be a lot of questions. So I'm expecting a decent amount of to and fro. So the first question is, and anyone who wants to answer, you can like type it in the chat. So what information does this shape convey to you? So from what we have already discussed, this shape conveys two pieces of key information. What are those? Okay, yes, rows and columns. Yes, yes. Okay, so yeah, most of you are getting it right. And what does this part mean? 3. So 512 and 512 is the image size, which is height 512 pixels and width 512 pixels. What does 3 mean? Yes, correct. So good. So all of you are with me so far. So this 3 basically means like it is like each pixel has like 3 different channels. So in case you want to see how that looks like individually, you can see the image array. And this is the first pixel. And you see the values are a bit on the higher side. So the first pixel is on the top left. So you see this is a light pixel, right? And if you see the bottom right pixel, that will be the last one. And if you see the values, you see the values are a bit on the lower side. So you can say that this is a darker pixel. And the individual numbers here represent the intensity of the red, green, and blue channels respectively. Okay. Another question. So what is the maximum and minimum brightness an image can have in absolute terms? And also, how do we find the brightness of the entire image as a percentage? So this is something which we have already discussed. Yes. So the maximum brightness is 255 and the minimum brightness is 0. And how do you find the brightness of an image as a percentage? Not able to upload image. You don't need to upload anything. We are loading the image from a URL. It's a public URL, so you should be able to access it. Yes, so pixel by total. So if you click on this cell, you will get this. So what we do is we get the mean of all the pixel values, and then we just get a percentage, and 255 being the maximum. So this will give us the percentage brightness of this image. So this image is like just 50% bright, which is like almost midway. So you can say that the average value of each pixel is around 122, 123. What is the use of percentage here? So this is just basically just to kind of understand how, so when you like alter the brightness of an image, this is what happens at the back end. If you increase brightness by 1%, all the pixel brightness, all the pixel values actually increase by that percentage. Okay, so now let's come to the core of the workshop, which is tweaking the image properties. Okay, so what we will do now is we will change a few of the image properties, like say brightness, color, contrast, and sharpness by a factor ranging from 0 to 2. So we will use a Python imaging library's built-in functions, which is brightness, color, and contrast. all of them will load the image, and then we use the enhance method of that function to enhance those properties by a factor which we choose. So first, let's start with brightness. So if you execute this cell, you will see that I have enhanced the brightness of the same image between which packages I'm using. I'm using Python Imaging Library, PIL. It's installed in Colab, but you don't need to install it. Okay. So here you see that I have changed the brightness ranging from a factor of 0 to 2. So the factor 1 is basically the original image. If I make it 0, I basically multiply the image, all the pixels by 0. So all we get is a 0, a completely black image. And if I like enhance everything by 2, I get a very bright image. So the average value of the pixel intensities have like doubled basically. So at the pixel level, each pixel is simply multiplied by the factor to get its new value. So changing brightness is that simple. You just multiply the image by the factor. So you can also do that in like NumPy, use standard multiplication of arrays. Now let's see what the individual image values look like. So let's see the first image, right? The first pixel. So this is the first pixel of the original image. So on the top left. So I told you like this is a bit of a brighter image, so it has higher values. So when you enhance it by a factor of 0, you basically multiply each individual value by 0. So you get 0 for all the channels and you get absolute black. So enhancing it by a factor of 1 is multiplying it by 1. So you get the same image, and enhancing it by a factor of 2. Yeah, like you see every image like has been like every channel has been multiplied by 2, and since 255 is the maximum value, you cannot go beyond that. Even if say your original value was 250, you multiply it by 2, you will still be stuck at 255. You cannot go beyond it. Okay, so if you see, this is almost white, so this would have been like absolute white if the third channel also would have been 255. Okay, now so this is another task for you. So we have these 9 pixels. I need someone to tell me what will happen if you multiply these pixels by 0 and 255. Like you enhance them by a factor of 0 and 255. Maximum factor is not 2. I mean, the maximum factor can be anything. You can have a maximum factor of 100 as well. So if you multiply this by 0, you get black. That is correct, because like anything into 0 is 0. Now, what happens if you multiply this by 255? Like you multiply all the individual pixel values by 255. Say, even if your pixel was 1, pixel value was 1, you multiply it by 255, it becomes from almost black to absolute white. 0 gives black, 255 gives white. Okay, those who are saying white are almost correct. So let's see what the solution looks like. Okay. So it's a bit more complicated than you might think. So for factor 0, it's all black. So like everyone guessed, because you multiply anything by 0, you will get 0. Now for factor 1, we get the original image. Now for factor 255, you see it's not absolute white. So can someone tell me why the top row has not changed at all? Except for RGB, all white. Yes, correct. And also the lower bottom, because the lower left was already 0, 0, 0. So multiply it by anything, you will still be getting 0, 0, 0. So that won't change since 0 is there. Yes. So the top row, you won't get absolute white because you see the channels here. So for the first pixel, it's 255, 0, 0. Right. So you multiply this by 255, what do you get? You still get 255, 0, 0, because anything multiplied with 0 is still 0, right? So something which is absolutely red, absolute green, or absolute blue, you multiply it by anything except 0, you will still get the same values. And for the middle row, like since this had non-zero values in all the cells, you multiply it by 255, the maximum value, it will be maxed out to 255. So the middle row is also white, and the bottom, like the white and gray, again, since these had non-zero values, you will end up with them being like maxed out at 255. Now, if you see something interesting here at factor 0.5, so what happens is like the colors are more or less the same, but the image looks a bit dull. That's because like even though the top left is still red because green and blue are 0, but the intensity of red has decreased. So in the original image, it was 255. Now it's 127. So it's red, but it's a little duller red. It's not as bright. And same if you see for a factor of 1.5, we observe the middle row. So the colors have been enhanced a bit. They are brighter a bit. So you see the middle color, the green, it's bright green now, because earlier, like it was say 150, 200, 100. So the green intensity was 200. Now it's 255. Okay, now another task. So we have the below image. This is the original image. So how will this look like if we enhance it by a factor of 10? Can we use the same code for MRI image processing too? Yes, actually you can use this for all, but the problem with MRI images is they are mostly 3D images. So they'll consume a lot of memory, and it's ideally not recommended to use Colab for those use cases unless you have a very beefed up hardware. And also, like, this is very basic code. If you want to like do hardcore image processing, you should use like proper libraries like which are built for image processing. Okay, coming back to the question. So what will this look like if you enhance brightness by a factor of 10? Basically, you multiply each image by 10. Only black will be visible with some shades of gray. Okay, very close to the answer. Let's see how it actually looks like. So you see this. Okay, so there's this weird purple color, right? Why do we have this purple color? Yes, so those pixels which value less than 25 will still remain there. So basically what has happened here is, if you see these purple patches, these correspond to the darker portions of this image, right? And by darker portions of this image is like these pixels, some of the color channels of these pixels have a value less than 25. Now what happens if you multiply this by 10, you get 250, you don't get 255. So since you don't get 255, it does not convert to black. And since most of these you see are already say purplish, which means the blue part of that image is basically between 0 to 25. So when you enhance it, the green and red become 255, and the blue part remains it. So if we see this now, so this is an explanation of what happens. So if you see this image looks like it's almost black, but if you see the pixel values, right? So for the first, so this is basically like 6 different, and basically 3 different pixels together. So for the first, all of them look the same, but they're not actually the same. For the first, the green and blue have a pixel value of 1. For the second, red and green have a pixel value of 1. And for the third, red and blue have a pixel value of 1. So if you multiply them by 10, this is what you get. So now, except those which were 0, everything else has been maxed out. So this is why you get like purple or violet in this part, because like for these images, like blue was less than 25, or blue was close to 0. Okay, so I hope everyone is clear with this section. Any questions before move on to the color part or the saturation part? 255 into 255, what brightness? So since 255 is already the maximum, you will get the same. It will be absolute white. Is there an exercise on PyDACOM library? No, not in this workshop. So this is just an introductory workshop on image processing. So basically designed for those who have like little to no experience with image processing on Python. Can you explain why purple again? Okay, so in your case, you see this pixel, this is like, this image consists of 3 pixels, left, middle, right. So the middle image, if you see, this is the pixel values. Red is 1, blue is 0, green is 1. Now, since blue is 0, if I multiply this by anything, it will stay 0. Now, if I multiply this by 255, what I'll get is 255, 0, 255. And since the center pixel still remains 0. I just get a combination of red and green. And what does red and green give you? Like combine red and green light, you get purple light. Was that clear? Why purple? And also one important distinction to notice is these are light combinations. So these are not pigment combinations. So this is basically the opposite of what you get when you mix red and green colors together or like paint together. So because that works on absorbing light by the principle of absorption of light, and this works on the principle of, say, emitting light. Was that clear? Okay, great. So moving on to the saturation part. So first, let's see how, like what saturation actually means. So you see here, I've changed the saturation from 0 to 2 again. So saturation is basically a measure of the color intensity. Okay, so when you see 0, it's basically converted to the image to grayscale. So there is no more color left in the image. And if you see for saturation, enhancement factor 2, the colors have been highlighted. So this is basically what happens when you auto fix images on Google Photo, something like the colors look highlighted. So saturation is basically a measure of the relative intensity of colors of an image. So by relative intensity, what I mean is the difference between the colors between individual color channels. So decreasing the saturation will reduce the difference between individual color channels by making them closer to their average. So basically, if what it will do is for each pixel, the 3 different color channels, it will bring it closer to the average, and thereby reducing the color difference of each individual channel. And if you increase the saturation, it will increase the difference. So to make this clear, let's see how this looks like at the pixel level. Again, we will start with the top left pixel. So you see, this is the individual color channel 226. So red is the highest, followed by green and red, blue, and green. Sorry, red, green, and blue. So what happens if I enhance the color factor by a factor of 0 is like all the pixel values have been moved closer to their average. So if you see the average for this is 162, and now all the pixel values have the same value. And since everything has the same value, it basically converts it to a grayscale image with a, like, say, value of 162 out of 255. And now if I enhance the color by a factor of 2, what happens is it spreads the color from their average. It basically increases standard deviation of the image of that pixel. So if you see, the average was 162. Earlier red was like 226. Now it's further from 162. It became 225. Green was 137, and now it's 112. It's also further from 162. Sorry, 137. And blue was originally 125, and now it has been moved further from the average of 162. So it's now 88. Now again, the same tasks. This is the image. So what will happen if you like enhance the color or the saturation by a factor of 0 or by a factor of 2? What will you get? Why has red increased? That is because red was already above the average. So what we are doing is we are pushing every pixel value away from the average, which we enhance it by a factor greater than 1. So since it was above the average, so the original value was 226, average is 162. So it has to be more than 226 now. And the other two were below the average. So green was 137. So to increase its distance from the average, we have to reduce it. And same with blue. So earlier it was 125. Now we are like moving it further from the average. So we reduce it. Did that answer the question? Okay, now coming to the question which I had asked. So how will this change for a factor of 0 and factor of 2? So 0 should be, as I just mentioned that. What will happen if we enhance this by a factor of 2? Factor 2 equals to gray. Let's see if that's true. So this is what happens when we enhance this collection of pixels by a factor of 0. So basically, like, everything converts to grayscale. So this was the original. If you see the pixel values, this is how it looked like. And you multiply this by 0. So basically every pixel is now, the color channels are now being converted to their averages. So you see the value of color channel for each pixel will now be the same. They'll only change in the intensity. So you see here for 0, 0, 0, it still remains 0, 0, 0 because again, like it was already at the average. So that won't change. It won't increase or decrease the brightness or the mean of the image. It will only bring the color channels closer or further from their mean. So that is why when you see the bottom row, there is no change because all the individual color channels were already at the average. At the top, since the difference was already the highest, if you make it 0, they will all be converted to their averages. And again, you will see a different shades of gray. And similarly for the center one, irrespective of the value of individual color channels, what you will get is their average. So again, it will be different shades of gray. Okay, and so just a disclaimer here. So the ideally, like this should be the average of their color channels, but since we're using the Python imaging library, the actual pixel values won't be the average because like image enhance does not use a direct formula. It does not use the average formula to manipulate pixels. What you can do is you can like follow this link, so that points to a Stack Overflow answer, which will explain the how PIL Python imaging library actually enhances color, if you want to delve into the details. Now enhancing the same image by a factor of 2, and this is what we get. So each pixel, the color, the prominent color has now been enhanced. So for the first 3, so it was already like as red as it can be. So there will be no change in the first row in this case. In the second row, we will see that, so the first pixel, red was the highest. In the second, green was the highest. And in third, blue was the highest. So we will see that red has been enhanced, green has been enhanced for second, and blue has been enhanced here. So what has happened is the value the pixel which was already above average has now been increased. The pixel which was below the average has now been decreased. And again, in the bottom, you won't see any change because like all the pixels were at their averages, even though their averages are different, but they were at their average. Okay, any questions here before we move on to the next part? Okay, so moving on to contrast now. Again, we are seeing that I've like enhanced the contrast by a factor from 0 to 2, and we see what difference it makes. So contrast is basically the difference in brightness between the pixels. So this is not a difference between individual color channels. It's a difference of brightness between individual pixels. So increasing the contrast will increase the difference between pixels. Just to remember, saturation is the difference in intensity values between individual color channels of the same pixel. Contrast is the value of individual pixels. So increasing contrast will increase the difference between the brightness of individual pixels, and decreasing contrast will decrease it. So in case you see here, for the first case, since we have made contrast 0, now every pixel is as bright as the other, right? And every color channel as well. So again, this becomes a completely gray image. Now in this case, on the bottom right, if you see the images, if you compare it to the original image here, the center image, the pixels which were bright are now brighter. The pixels which were dark are now darker. So what has happened when we have enhanced the contrast is we have actually increased the difference between the bright and the dull pixels. So it's almost the same like the saturation thing, but here in case of contrast, we are dealing at the pixel level, not at the color channel level. Enhancing is like increasing the prominent color. That was for saturation. So I'm assuming you're talking about contrast. So enhancing saturation will increase the prominent color. Enhancing contrast will make the brighter pixels more bright and the darker pixels less dark. So it's easier to differentiate between individual pixels. Okay. Yeah. So in case like you want to delve more deep into like difference between contrast and saturation, you can follow this link. It will take you to a Quora answer where it's like described in detail. So let's see what happens at individual pixel level. So again, like the factor 1, you see, this is the original image. So for factor 0, you see that all pixel values are now the same. So there is no standard deviation between the brightness of individual pixels. So for factor 1, you see that the standard deviation between individual pixels with the mean of the entire image was 99. So what we do is, when we enhance contrast, is actually we multiply the contrast factor with the standard deviation. So if you reduce enhanced contrast by a factor less than 1, you will reduce the standard deviation. So the brightness values of pixels will come closer together. If you increase it, so the brightness value of pixels will become further from each other. So like for 0.5, you can see that the images, although you can still make out individual images, but they are more difficult to make out than before, because what has happened is the value of each individual image, it has now been moved closer to their average. And if you increase it by a factor greater than 1, the value has now been moved further from their average. So in case you see here, so like here the individual pixels are like, you can like readily differentiate between them. And in this case, you see for the first 2 pixels of the middle row, so you cannot differentiate between them, is because their average was the same. Okay, was this part clear? Why would green become yellow? Are you talking about the center pixel, this one? Okay, why will it become yellow? If you see the pixel values, right? So 255, 177, 77. So what has happened is, what we are doing when we like increase the standard deviation is, so this does not operate at the color channel level. So any changes to color channel will be a result of trying to like increase or decrease the brightness of the image. Now, what's happening here is, so 255, this will obviously not change because it's already the maximum value. 177, it's already higher than the average. So we are increasing it more, and the max we can increase it to is 270, is 255. Now 77, it's less than the average. And by the average, I mean like the average across the entire image, not just the individual pixel. So since this is less than the average, we like reduce it to 0, because we have to like max out the difference. So this becomes 255, 255, 0. And you see the second pixel again, it's 177. So it's higher than average. We increase it to 255. This is again 255. So already the highest. And 77, we reduce it to 0. So we are basically left with 2 same pixels here. So irrespective of what their original values was, this has now like become the same value after enhancement. It has become 250. The RGB values of both these pixels are now the same after enhancement. So that is why like earlier it was green, but now that we have enhanced it and like maxed out the red for this image, we are like red plus green gives you yellow. And since like the blue part is 0 here, that's why it does not become absolutely white. So if the blue was 255, this would have become completely white, like it is for the last 2 images. And for the last image here, the cyan image, since red is 0, you have like green plus blue, which gives you cyan. Did that answer the question? Okay, great. Why did standard deviation increase? Because that is what contrast does. How does it calculate? For that, you will actually have to go into the PIL image enhanced code and see how it calculates. But that's the intuition is the standard deviation. We are like increasing or decreasing how the individual pixel values from the average of the entire image. Where do you get to see the average? You don't get to see it, but in case you want to calculate, you can just do image array and you get the mean. So that is how I had done it when I got the brightness here. Image array, you got the mean. So if you only run this part, you'll get the mean of the entire image. So that is the reference point. Okay, all good here? Any further questions on this part before we move on to flipping and rotating? Okay, so let's start with flipping and rotating. So first, Like anyone who can tell me the difference between flipping and rotating? I mean, these terms sound like almost the same. Sometimes we might use them interchangeably, but like when it comes to arrays or when it comes to images, these are very different. Rotating angle rotation, yes, correct. Flipping mirror, yes, correct. So basically they work at a different axis. So flipping is basically like flipping the pages of a book. You have an axis running at the center of the book and you flip it on that axis. Rotating is, think of it like, say you hold your notebook over a pencil and you would have rotated as a child, right? So that is basically rotating it. So it's basically the axis in this case passes through the center of the plane of the image perpendicular to it. So that is rotating. So let's start with flip. And for this case, we will use the OpenCV library. I told you like we have two basic libraries which we used for image manipulation. One is PIL, which we have been using as of now, Python imaging library. The other is OpenCV library or Open Computer Vision. So we use CV2. So for a flip, what we will do is we will use the CV2 flip function. It will take the image and a value between 0, 1 and -1. So if you supply it 0, the image will be flipped vertically. For a value of 1, it will be flipped horizontally. And if you give -1, it will be flipped both horizontally and vertically. Let me show you how that will look like. So you have imported the image. So again, this was the original image. And let's see what happens once you have flipped it. So 0, you have flipped the image vertically now. So it's upside down. So for 1, you have flipped it horizontally. So this is basically like the mirror image. And for -1, you have flipped it both horizontally and vertically. So it's upside down, and then you have the mirror image of it. Now, another question. So this is, now consider this to be an array or an image. So how will this change for different flips? Like for a value of 0, 1 and -1, what will be the new matrix? Like what will be the position of individual rows or columns or values? And I hope everyone is also like following this on their notebook, as in like you are in the same place where I am. It'll be easy to understand. So what happens to the, like, say for the first example, when we flip it vertically, what happens to the first, second, and third rows? What happens to the first row? One and three interchange. Yes, correct. So when you flip it vertically, think of it as an axis which is passing through this, and then you interchange everything. So the middle row stays the middle row. The first row becomes third and third becomes first. Now, what happens if you flip it horizontally? Same concepts, but a different axis. First and third column. Yes, correct. So in case you're flipping it horizontally, what will happen is, think of an axis passing through 1, 4, and 7. And then the first column, you interchange the first and the third columns basically. So first column becomes third column becomes first, and the middle column stays as is. Now what will happen for -1? You combine both of these outputs together. What will you get? Yes. So what happens is, in this case, now think of it as the same two operations, but applied one after the other. So first you flip it either horizontally or vertically. Like say, for example, I'll first flip it vertically. So 0, 1, 2 goes to the bottom, 6, 7, 8 goes to the top. And then I'll flip it horizontally. So 6, 7, 8 is at the top. So this becomes 8, 7, 6. This becomes 5, 4, 3, and this becomes 2, 1, 0. So the only pixel which remains unchanged is the center pixel. So that remains as it is. So let's see how this will actually look like. So this was the original. If you flip it vertically, so this goes to the top, this comes to the bottom. Flip it horizontally, 0, 3, 6 goes to the right, 2, 5, 8 goes to the left. And you flip it both ways, so this goes to the top, and then you interchange the values. This comes to the bottom, and then you interchange the values, and you're left with this. So the only cell which remains unchanged is the center cell. And also you can this is basically like flipping it both horizontally and vertically is the same as rotating the image by like say 180 degrees. So if you see, if you rotate this by 180 degrees, 8 will come here, 7 will be here, 6 will be here. So this is what you get here. So we will also come to that. So rotating is a bit more straightforward. Let's see how this works. So the first is the original. So we give the angles which we have to rotate it with. So first is the original 0 degrees, second is 45 degrees. So what it does is it fills it by default, it will fill it with black, but you have like other arguments available as well. If you just want to extrapolate the cells at the edge, or if you want to fill it with any other solid color, you can do that as well. 90 degrees, so this, like, think of it as like rotated by 90 degrees. 180 degrees is, like I said, it's just flipping it vertically. 270 degrees is again like rotating it clockwise by 270 degrees. Now the same image, how will this change if you rotate it by say 90, 180 and 270 degrees? This will rotate in anti-clockwise direction. Sorry, my bad. Yeah. So if you see here, 0, 45, this are rotated anti-clockwise, 90 degrees, 180 and 270. 180, obviously it makes no difference. But yeah, this will rotate it in anti-clockwise direction. Can you use negative values? Yes, you can use negative values. If you give minus 45 here, so this image will be rotated to the left. Let me show you how that will look like. So minus 45 will basically, like, think of it as like clockwise rotation. Okay, so what will happen if you rotate this array by like say 90 degrees, 180 and 270? 180 should be easy. We've just discussed this before. So first, let's start with the easy one. What will happen in case we rotate it by 180 degrees? Rows will be treated as column for 90. Yeah, I mean, but the rows will change to columns, 0, 1, 2. The first row will become the first column, the second row will become the second column, and the third row will become the third column if you rotate it by 90 degrees. If you rotate it by 180 degrees, it's the same as flipping the image vertically. So first row goes to the bottom, third row goes to the top, center stays as is. 270 is the easier way to visualize this is by rotating it by minus 90 degrees. So how this will look like is, so this was the original rotated by 90 degrees. So the rows have now become the rows have now become the columns. So think of this and then just turn it 90 degrees anti-clockwise. So 0, 1, 2 becomes 2, 1, 0, 3, 4, 5 becomes 5, 4, 3, 6, 7, 8 becomes 8, 7, 6. Rotate by 180 degrees is again like just rotate it here. It's the -1 situation which we had for flipping it both horizontally and vertically. And 270 is also the same as -90. So basically you take this and rotate it 90 degrees clockwise. So 0, 1, 2 will become 0, 1, 2, the third column. 3, 4, 5 will become 3, 4, 5, second column. 6, 7, 8 will become 6, 7, 8, first column. What about 45 degree? Good question. Let's check. So since we had those interpolations, so this is what you get when you rotate it by, change it here, won't use the scale factor. Okay, so this won't take fractional values. So what I'm doing here, I'm not using the PIL library here to rotate. I'm just doing an array operation here. So I will have to see what values it takes. K is an integer. Okay, so yeah, this cannot be, so rotate 90 will only do it at multiples of 90 degrees. So there will be, okay, let's, we won't have a rotate option. Yeah, some pixels will become 0. So that will depend on what the image shape is. So the pixels at the corner, right? The pixels at the corner, by default, they will become 0 because that's the black thing. Some pixels will actually move out, so they won't be a part of the image anymore. So if you see here, right, the pixels which were originally at the corner, they are now out of the frame, so they won't be in the part anymore. So what I'm assuming, I cannot say for sure, if you change this to say rotated by 45-degree clockwise, you will be left with something which looks like, so this is 0, 1, 2. So this will become 0. So the corners are all 0. Center will be 4. So this will be 5 because this won't be 5. So 5 will be 90 degree. I cannot give you the exact values. It might be so these are the values I'm sure of. So this will depend on like what the actual dimensions of the image are and how that extrapolation is being done. K value 0.5, it won't work. It will only take integers for K. So because this is the rotate 90 method. It's working for K 0.5, is it? Oh, okay. I don't know what I did wrong the first time. Okay, so this is what you get, 630,741, but this is not 45 degrees. K 0.5 is basically minus 90. So in case you do fractional, it actually changes this clockwise. So this becomes minus 90, I am assuming. So if you do 0.25, it will become minus 180 or minus 270, yes. So yeah, you cannot use fractional values of K for this rotate 90 function. It will only do it in multiples of 90. But if you want to play around, you can like just explore the image, the array values of this image, and see like what the array values are at the edges and at the corners. Okay, good discussion almost at the end. So what's the end goal basically? So after you have made all the manipulations, what you need to do is basically like say saving or downloading the image, right? Because an image in a Jupyter notebook is like useless. So you need to like after you're done with your batch process or even like individual processing, you have to find a way of saving it. So what you can do is you can use the from array save function here. So it will save on the left. If you see, you will have this option, the files option here. So currently there will be nothing. If you just do this, the last image, right, that will be saved as image.jpg, and if you double click on this, you'll be able to see the image. So this is the original image. And if you want to download this, please say about duplicate photo difference. So that is something which is like kind of out of scope, but it's a like very big area altogether. If you want to find like the exact duplicates, you can just compare. Since it's basically an array, you can just do a subtraction of array or just compare arrays. If there's no difference, it's basically a duplicate image. But in most real world cases, there are a few pixels different. In case one image has been uploaded to some provider, there's some compression method applied. So it's actually a separate field of machine learning altogether, finding duplicates. But yeah, the most like simplest or most intuitive method of find duplicate is just like check the arrays and check if both the arrays are the same, then it's a duplicate image. Okay, and if you want to download this image now, you can either like click here, download, or if you want to do it programmatically, you can use this import files, download. Once it runs, it will give you an option where you want to save it. And then you can save the image. So cool, we are almost at time. So before I take in the last questions, let me just like try to wrap up what we have learned so far, like very fast in this 1 hour. So first is like we have learned how an image is represented programmatically. How can you download multiple images? You can just run this in a loop in case you have multiple images. Files download can be run in a loop. So we have learned how an image is represented digitally and what's the difference between a monochrome or a grayscale image from a color image. Then we have learned how to perform basic image adjustments like say brightness, saturation, contrast, and orientation like flip and rotate. Then we have learned how to save and download these images from Google Colab. If you're working locally in your local Jupyter notebook, this might not be needed. But in case you're using Google Colab, because this is the best option some of us have, you can use these methods to save or download the images. And where can you use this? So first is if you want to like be fancy or if you want to show off in front of your friends, you can use this code to enhance images without using third-party software, which might like save your images or whatnot, do what you might not even have imagined with your images. Second is image augmentation. So this is basically a concept in machine learning wherein we increase the images available for training a model. Say, suppose you want to train a computer vision model or an image classification model, but you don't have enough images. So what do you do is you cannot exactly duplicate images to train it to a model, because that's the worst idea ever. You cannot make duplicate copies of your training data and train the model with it. So what you do is the same image, you enhance it a bit, you change some of the properties so that for the model it becomes a different image, but it's actually the same image. And then you can use those images, you can use that expanded data set to train your model. So say what has happened here is we've started with one image, but just applying different values of say brightness, we got like 9 different images. Now applying different values of saturation, we got 9 more. If you like do all of this cumulatively from that one image, you can get what 9 into 9 into 9 different images. And if you like make more variations, you can get an endless number of images which are different in some pixel values to train your model. Right, so like this is a separate field of like machine learning altogether, like increase the data set to train your image or to train your model. So yeah, so that is some that is also like if you're interested in that you can use this knowledge there as well. So yeah, we have like say 1 minute left. So in case anyone has any questions, this is your time. Link for the notebook is already shared. Projects you work as a data scientist, image processing is used. So there is one where I used that was actually my first image processing project where I created a model which will identify diseases using a photo of their leaves. So that was just a personal project, but like we had 3 different diseases which could be identified, and you use these techniques to increase the size of data set and then train the model, and the model will tell you like if it's a healthy leaf or a diseased leaf and which disease it is. Okay, any other questions? In case you have any questions later on, you can like drop me a mail. My email ID is mentioned here, or connect with me on LinkedIn. It will help in case you just send me a note with your connection request that you attended this session and you had this question, and I will make sure to answer it. Might take a while, but I will get back to you. So we are on time. Thank you all for joining, and thank you for the AV team for having me. Thank you.
Thanks a lot, Siddhant. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful as well, and hopefully we can conduct more such sessions with you in the future.